Okay, so today we will be the last part of this topic is of this chapter is remaining uh, arithmetic geometric series, which is a combination of arithmetic progression and geometric progression. And after that, we will also do some applications of this inequality. Which inequality? AM greater than GM greater than HM. Arithmetic mean is always greater than or equal to geometric, always greater than or equal to harmonic mean. Okay, so first, let's study what is the arithmetico-geometric series. Just 1 second, students. Yes, the screen should be visible now. Arithmetico-geometric series. So if you consider a sequence of this format, let's say as sequences, first term is, let's say 1, 3x, 5x square, 7x cube, 9x to the power 4, so on and so on and so on. Can you see that now this type of sequence is called as arithmetico-geometric series. Why? Because the coefficients here 1, 3, 5, 7, 9 that forms an arithmetic progression, and the x system which is there, x raised to 0, x raised to 1, x square, x cube, x raised to 4, that forms a geometric progression. Okay, so this is the combination of arithmetic and geometric progression which is called as arithmetico-geometric series. So here the coefficients 1, 3, 5, 7, 9 dot 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 are in AP, and x to the 1 with along with 1 it was x to the power 0, along with 3 it was x to the power 1, then x square, then x cube, and so on are in GP. So how to calculate the sum of this formula, sum of this sequence? So let's solve one sample question. Let's say if I give you evaluate, we will derive a formula also, but direct derivation, if I tell you, that will you will get confused with the derivation. So let's understand one question with the help of an example only. Evaluate four minus 9x plus 16x square minus 25x cube plus 36x to the power 4. Or 1 minute. Okay, if you have written it, don't cancel it. We will solve this question set afterwards. First, we will consider application. Let's say evaluate 1 plus 3 plus 6 plus 10 plus 15 plus 21 plus 28 plus dot 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 up to n terms. Now here we are studying applications of geometric series. The concept that will be used, the method that will be solved to find sum of an arithmetic or geometric series, the same method will be used to solve this type of summations. I hope you can understand the logic, how this sequence is being formed. 1, 3, how these numbers are obtained. Can you guess the logic? The logic is, first I am adding 2, then I am adding 3, then I am adding 4, then 5, then 6, then 7, then 8, and so on. This way I am forming the sequence. Think for a while how to calculate the sum, otherwise I will tell you.
Sir, one scroll down, sir.
Freen, are you getting how to start? Just tell me how to start. You can unmute and start without actually solving the final, without actually getting up to the final step. You can unmute yourself and tell me, so this way we will start. You're getting how to start the question?
No, sir, I'm not getting.
Yeah, Freen. Okay. See, Sn is equals to 1, 3, 6, 10, and so on. What I will do is, I will again write Sn. But now I will shift the sequence 1 terms ahead. So 1 here, I will write over here, 3 here, 6, 10. The same sequence I am writing in the same order also. No change in order, but I am shifting it 1 position forward. And here it will be Tn, last term over here. Here it will be whatever was the n minus 1th term. Okay, got it? So now if I do the subtraction, on subtracting these two, can you see that 0 will be equal to all? Now from here, all these terms form a pairs. 3 and subtraction 1, 6 minus 3, 10 minus 6 means term minus its previous term, 15 minus its previous term, then whatever it is, nth term minus its previous term. They will form a nice, this is 1, and 3 minus 1 is 2, 6 minus 3 is 3, 10 minus 6 is 4, 15 minus 10 is 5, up to here, whatever that difference is. Here, whatever that difference will be there, plus something, and here subtraction Tn. Do you get this? These will be two different terms, and this will be, these terms will survive separately. One will survive separately, Tn will survive separately, and these differences will form an arithmetic progression among themselves. Okay. So now, how many terms are there inside the bracket? Inside the bracket, can you see that? So we are taking difference from second to nth. Second term difference, third term, fourth term, fifth term, and so on up to nth term. So there are n minus 1 terms. From second term to nth term, there are n minus 1 terms. Do you get it? Or here you can, in the downward part, you can see from the first term up to the n minus 1th term, there are n minus 1 terms. So n minus 1 differences. So here can I write, there are n minus 1 terms in total, n minus 1 terms in total inside the bracket. Got it? Yes or no? So Tn, I just bring this Tn on the LHS. Tn will be equal to 1 plus this sum of this arithmetic progression 2 plus 3 plus 4 plus 5 plus so on and so on and so on up to how much? Up to n minus 1 terms in total. So how do you calculate it? Tn will be equal to 1 plus sum of this arithmetic progression is what? So sum of this arithmetic progression is number of terms upon 2, n upon 2, 2a plus n minus 1d. But the only difference is here n is not actually n. Here n is number of terms which is n minus 1. Are you understanding what I'm saying? Number of terms upon 2. Number of terms is n minus 1. Number of terms upon 2, 2 times a. 2 times a is 4 plus number of terms minus 1. Number of terms minus 1 is n minus 2. Means n minus 1 minus 1. Number of terms minus 1 into d. What is the common difference? The common difference is 1 only. Is this clear? And then Tn is equals to 1 plus n minus 1 upon 2. This bracket, if you solve, it turns out to be equal to n plus 2. This is n minus 1 upon 2. This is n plus 1 upon 2. So Tn is equal to n square minus n. This is n square minus, yeah, 1 minute. Sorry, n square plus n. N square plus n negative 2 upon 2 plus 1, which simplifies to Tn is equals to n square plus n upon 2. Okay. And once you know the nth term of, if you got this nth term, just for a just to be extra careful, we can verify also. First, put n equal to 1. So 1 square plus 1 upon 2, we get the first term as 1. Yes, okay. If we put n equal to 2, so 2 square is 4 plus 2, 6. 6 upon 2 is 3. Yes, second term also we are getting 3 square, 9 plus 3, 12 upon 2, 6 also we are getting yes. So our verification is going on perfectly. So nth term is obtained. So now you have to calculate Sn. Sn is what? So Sn is nothing but T1 plus T2 up to so on up to Tn. So you just have to calculate summation of n square plus n upon 2, where n varies from initial value is 1 and final limiting value is n. Or you can call it here I square plus I square plus I, where I varies from 1 to n. If n is confusing. T1, T2, T3, T4 up to Tn. So this calculation you can do. Shall I leave it up to this point? Pujit and Afrin, please reply.
Yes, sir.
Afrin?
Yes, sir.
Okay. So ahead, after this, you can do, I'm assuming. Okay. The summation separately, the summations questions that we have. So the concept involved was, so we just shift the sequence 1 unit ahead, 1 position forward. So that way only we will solve this arithmetical geometric series. Here inside the bracket, it was a simple AP. There something different may occur. So let's say now evaluate this second. Evaluate sum of the series four minus 9x, the question that I gave you earlier. 4 minus 9x plus 16x square minus 25x cube plus 36x to the power 4 minus 49x to the power 5 and so on and so on and so on up to infinite terms. here a slight catch is there in the question. Okay, slight twist is there. Be careful. S is equals to 4 minus 9x plus 16x square minus 25x cube plus 36x to the power 4 minus 9x to the power. So numerical wise, we can see that 4 and 9 numerically difference is 5, 9 and 16 numerically difference is 7, 16 and 25 numerically the difference is 9, 5, 7, 9, 11, 13 and so on. So maybe that gives us a hint that yes, something that we can do of subtraction. But here now signs are alternating. Two problems are there. So first of all, if the first problem is if everything would have been in positive, plus 4 plus 9x plus 16x square plus 25x cube plus 36 and then plus 49, then it would have been comparatively easier. And the second is now here x square, that is also creating a problem. So even if I shift it one step ahead, 4 minus 9x 16x square 25x cube, even then sir it's a problem, because how can I subtract them? Yes or no? Correct. So instead what I will do is I will, instead of writing as the sequence s as it is and shifting it one step ahead, what I will do is I will multiply this x multiplied by s. I will write x multiplied by s. So what this sequence becomes, 4 into x, this becomes 9x square. Sign I will adjust. Okay, this will become 16x cube. This will be 25x to the power 4. Here it will be 36x to the power 5 and so on. Okay, yes or no? 4x minus 9x square plus 16x cube minus 25x to the power 4 plus 35. Now, since the signs were alternating, numerical value of subtraction was same. Numerical value of subtraction was same. So you can see that signs are alternating means addition wise they will be same. Addition wise they will form an AP. Minus 9 plus 4 minus 5. 16 minus 16 plus addition is we are doing minus 9, addition 4 minus 5. 16 addition of minus 9 7. Minus 25 addition of 16 minus 9. Okay, so now I will do the addition over here. So if I do the addition, it turns out to be s into 1 plus x. This is equal to 4 as it is, minus 9x plus 4x is minus 5x. This is plus 7x square. This is minus 9x cube plus 11x to the power 4 minus 13x to the power 5, and so on and so on and so on. Now this much part from over here, minus 5x plus 7x square minus 9x cube and so on. This is an arithmetic or geometric series. 5, 7, 9, 11, 13. Don't think of it as minus 5 plus 7 minus 9. Think of it as 5, 7, 9, 11, 13. This is an AP. Negative x, positive x square. Negative x cube, positive x raised to 4. Negative x raised to 5. This forms a GP. Yes or no? Where the common difference, the common ratio is of minus x. Minus x here into minus x, the second term positive x square into minus x is negative x cube into minus x is positive x raised to 4 and so on. So if I would have given you only this much question, evaluate minus 5x plus 7x square minus 9x cube plus 11x to the power 4 minus 13x to the power 5. How would you have calculated that? Are you getting it? This is the sum of this is the starting point of the sum, means the arithmetic or geometric series. I have given you directly JEE level question. Okay.
Yes, sir.
So to counter that, we will again use, forget here, don't think here that it is 1 plus x times s. It may be, think of it, that is bothering you, 1 plus x times s. Think of it as some other variable, some other variable equal to this much. So now again here's a 4. If I just write 1 plus x times s, the same concept we are using again and again. 4 minus 5x, so write signs also afterwards. 4, 5x, 7x square, 9x cube. So difference wise we can see that here 11x to the power 4 and so on and so on and so on. Difference wise we can see that numerical difference 1, 2, 3, 1, 2, 2, 2, 2, 2, 2, 2, it will come out. It will come out. Okay, 1, 2, 2, 2, 2, 2, like in the first question that we did. 1, and then here it was an AP. So here also now 1 difference will come, and then 2, 2, 2, 2, 2, 2, 2. But here it is 4, here it is 5x and 7x square. 7x square and 5x, 9x cube and 7x square. So what we will do, instead of writing this sequence as it is, I will multiply it by x. This upper sequence 1 plus x into s, complete into x. So this becomes 4 into x, 5x square, 7x cube, 9x to the power 4, 11x to the power 5 and so on. And signature wise 4x minus 5x plus 7x square minus 11x cube plus this much and so on. What to do? What do you think? Whether we have to do subtraction or addition?
Subtraction.
Okay. So if we do subtraction here now, after you think, if I do subtraction, then here it will become minus 5x minus 4x, so negative 9. Then here it will become positive 12x square. Then here minus 16, 9, 12, 16. Again, it won't be of any use to us. Yes or no? We will do addition.
Yes, sir.
Numerical value is getting subtracted. Numerical, the magnitude is getting subtracted. So along with one of them is already, if it is negative, means along with the signatures we have to do addition. So here it will be on the right hand side. On the right hand side it will be 4. Then addition if you are doing, so addition it will be minus x. Then it will be plus 2x square minus 2x cube plus 2x to the power 4 minus 2x to the power 5 plus 2x to the power 6 and so on and so on and so on. And on the LHS what it will be? On the LHS it will be, so see, can you see this part, that 1 plus x into s and 1 plus x into s multiplied by x. So 1 plus x into s, 1 plus x multiplied by s I can take as common. You have to do addition only, no? The green part into 1 multiplied by the green underline into x. So the green underline, if I take as common, what remains is green underline outside, and in the bracket it will remain 1 plus x. So can I do here 1 plus x square? In one step I did it. Is the LHS clear?
Yes, sir.
Afreen?
Yes, sir.
Okay. So when I'm asking you questions, please reply that yes, it's clear enough.
Yes, sir.
Okay. So now here 4, and now this is a simple geometric progression. 4 minus x, and then here take 2x as common. So if you take 2x as common, you can take 2x square also as common. 2x square if you take as common, then what remains is 1 minus x plus x square minus x cube plus x to the power 4, and so on and so on and so on. So this will be equal to 4 minus x plus 2x square multiplied by, what is this sequence? This is a geometric progression with first term as 1 and the common ratio as negative x. Common ratio as negative x, so a multiplied by 1 minus r is 1 upon 1 minus r. This is up to infinity. So a, that is 1 multiplied by 1 minus x raised to infinity upon 1 minus x. I forgot to mention this in the question. Modulus of x is less than 1. So this will be equal to 4 minus x plus 2x square into 1 upon 1 plus x. Yes or no? Because this term is up to infinity, it is just the sequence, the sum of the sequence is just a upon 1 minus r. Yes or no? This is
Yes, sir.
Yes, sir.
because the numerator 1 minus r to the power n is almost, it is equal to 1 only. So now just solve this thing. So it is 4 plus 4x minus x square addition 2x square divided by 1 plus x is equals to 1 plus x. So s will be equal to negative x square plus 2x square. It comes out to be x square plus 3x plus 4. And this complete division by 1 plus x whole cube. This will be the answer. Okay.
Yes, sir.
The first question that we did here, we have applied the arithmetic geometrical series 2 times here. I will give a comparatively easy sum. Have you copied everything?
Yes, sir.
No, sir, but could you please scroll down, sir?
Okay. 1 minute. Let me give the question and then I will scroll down. Evaluate one plus 2x plus 3x square plus 4x cube plus 5x to the power 4, and so on and so on and so on up to infinity, where modulus of x is less than 1.
Sir, could you please scroll down a bit, sir? Sir, the questions, the second question. Yes, sir, 1 minute.
Can take the screenshot of it. Solve the next
1 second.
question. By the
Okay, sir,
time you
wait a minute, sir. I'll just take this screenshot. Took, sir.
are you getting Pujita?
No, sir.
Okay, see.
Sir, could you explain, sir?
While I'm explaining, write down. Okay. See, s up to infinity. S is equals to 1 plus 2x plus 3x square plus 4x cube and so on. If I write this s again as it is, you can see that this is a simple AP and GP combination. In the previous question, or at least it was a GP, you could see 1x, x square, x cube and so on. It was further complicated because 4, 9, 16, 25, this was not an arithmetic progression straightforward. The differences were in arithmetic progression. The differences 5, 7, 9, 11, 13 and so on. So this was a two-step question. This the shifting position and multiplication we have to apply 2 times. But here it is a simple, the sum that were the coefficients that are there, they themselves are in AP. So sir, if I just shift 1 unit ahead, you must have realized that we have to multiply it by x. This much at least you must have done, Pujita. Yes or no? So
Yes,
if
sir.
Yes,
I
sir.
just, yes, 1, 2x and 3x square, and then here it is 5x to the power 4. So if I just write 4x cube, this will be problematic. So I will just, instead of writing s as it is, I will multiply it by x. So on multiplying it by x, this becomes x. This becomes 2x square, 3x cube, 4x to the power 4, and so on. Now, if you do the subtraction, yes or no? 1 minus x times s. In the previous questions, it was the difference of signs. The signs were getting alternated. We're doing simple subtraction. 1 plus x plus x square plus x cube plus x to the power 4, and so on and so on and so on up to infinite terms. So it's a straightforward geometric progression on the RHS. 1x, x square, x cube, x to the power 4, and so on. It's a straightforward GP. Can you see this? Yes or no?
Yes, sir.
It's a straightforward geometric progression. And can you find the sum of this geometric progression? Yes, sir. It's a very easy formula. It is a upon 1 minus r. So a upon 1 minus r. 1 minus r. What is the r? R is equals to x only. The numerator 1 minus r raised to n. Mod x is given to be less than 1. Okay. Sorry, here it is s also. 1 minus x s. So what will be s? S will be equal to 1 upon 1 minus x complete square. Done?
No, sir. Could you scroll down? So what have you written in the third, not third line, sir?
Here,
This GP, sir.
1x x square, this forms a geometric progression, no?
Okay, sir.
Into x into x into x into x, geometric progression. And what is the sum of this infinite geometric progression? A upon 1 minus r, because r is less than 1. The numerator 1 minus r raised to n, 1 minus r raised to infinity, that will be 1 minus 0 only. No?
Yes, sir. Okay, sir. Done, sir.
Okay. Evaluate 1 plus 2 upon 11 plus 3 upon 121 plus 4 upon 1331. What is 1331? It's 11 cube. Okay. So on up to a general term is given by 1 upon n power n minus 1. Its coefficient is n. That n, the middle term is just given as a general term, how this series is generated. You put n equal to 1. So 1 times 1 upon 11 whole raised to 0. Yes, it is 1. If you put n equal to 2, 1 upon 11 whole raised to 1. So yes, 2 multiplied by 1 by 11. 3 multiplied by 1 by 11 square. 4 multiplied by 1 by 11. Come on, it should not take so much time. Chalo, see. If you're getting confused with that 1 upon 11, that 1 upon 11 will definitely cause a problem. So what I will do is let 1 upon 11 is equals to x. So what is he asking me? He is asking me to calculate. So this first term 1 as it is. What is the second term? 2 multiplied by 1 upon 11. So is it 2x? 3 multiplied by 1 upon 11 square. So is it 3x square? The next term, is it 4x cube? The next term, is it 5x to the power 4? And so on and so on and so on up to infinite terms. Correct? This is only what he's asking me. Reply yes or no.
Yes, sir.
Yes, Afrin. So this is what I've just replaced one. I've just took 1 by 11 equal to x for the time being, and I'm writing this series as s equal to 1 plus 2x, 3x square, and so on, so that my fractions, I can avoid the fractions. In the last step means I will calculate the summation in the formula of x only. And once I get the formula, lastly I will resubstitute x equal to 1 by 11. So this question we have already done. Just look at the previous question. 1 plus 2x plus 3x square plus 4x plus 5x raised to 4. The previous question that we did, modulus of x is less than 1. This question is has been repeated here. Can you see? So can I directly write, sir, s infinity is equals to 1 upon 1 minus x complete square from the previous question only. Yes or no? So what will be s infinity? S infinity will be equal to 1 upon 1 minus 1 by 11 its whole square. So that will be equal to sum of the sequence. This is 10 by 11. In the denominator, it is 10 upon 11 whole square. So the final answer will be 121 upon 100. Is this clear, Afreen?
Yes, sir. Sir, one scroll
Yes,
down.
sir.
That 1 by 11 was giving trouble to me, so I substituted it as x.
So could you scroll down?
More. This one you want to copy?
No, sir, done, sir. This one. Like down means yes, sir. This one, fourth one done.
Okay. Okay, done, Pujita?
Sir, no, sir. One scroll down, sir. I'll take screenshot. Done, sir.
Evaluate. One plus 4 upon 5 plus 7 upon 5 square plus 10 upon 5 cube plus so on and so on and so on up to infinite terms.
Yes, sir.
Done?
Yes, sir.
Pujita?
Yes, sir.
Okay. What's the answer? What's the answer, Afrin and Pujita?
1/4, sir.
1/4. And Afrin, what about you? No, it should be 35/16. Okay, see. Let 1/5 equal to x. Yes or no?
Yes, sir.
Now, the sequence that he's asking, the sum of the series that he's asking is 1 plus 4x plus 7x square plus 10x cube and addition and so on and so on and so on. Now I cannot write here just sir 1 plus 4x plus 7x square. That will be futile. No use of that. Okay, because 10x cube minus 7x square, I cannot do the subtraction. I will do x multiplied by s. X multiplied by s. Now this becomes x plus 4x square plus 7x cube plus 10x to the power 4 and so on and so on and so on. Okay. Do the subtraction. If I do the subtraction over here, now this will become 1 minus x times s. This is equals to, this 1 survives as it is, and the remaining part is 3x plus 3x square plus 3x cube, then it will be 3x to the power 4 and so on. Clear up to this point? So,
Yes, sir.
1 minus x into s, it will be equal to 1 plus 3x into, what if I take 3x common from here, 1 plus x square plus x cube and so on. Yes or no, Afrin? This here 3x,
Yes,
3x
sir.
square, 3. Okay. Now this is a simple geometric progression. You could have observed that here also you can see that this is a geometric progression. 3x into x, 3x square into x, 3x cube into x. But the geometric progression is starting from this point. Okay, 3x. 1 is not included in the geometric progression. Keep in mind. Because from 1 to 3x, the ratio is 3x. From 3x, if you multiply again by 3x, it should come 9x square. So exclude that one. That one is totally different. 1 plus 3x into, now what is this? Sum of this sequence, sum of this geometric progression. A upon, that is A upon 1 minus r. 1 minus r. R is x only. Modulus of r is less than 1. Here the reason is since modulus of x is less than 1. This is the sum up to infinite terms. 1 minus x times s. So 1 minus x times s is equal to, just multiplied. This is 1 minus x into 1, addition 3x. So this turns out to be equal to 2x plus 1 upon 1 minus x. One minus x whole square. So just substitute, resubstitute now x equal to 1/5. So this becomes 2 into 1/5 addition 1 upon 1 minus 1/5 is 4/5. 1 minus 1/5 is 4/5. Its square. So do the calculation. This is 2 by 5. 7 upon 5. 7 upon multiplied by 25 upon 16. So this turns out to be equal to 35 upon 16. Correct? Is it clear, students? Yes or no?
Yes, sir.
Okay, shall I move on to the next question?
Yes, sir.
Have you written down or taken the screenshot? Take the screenshot quickly.
Answer.
Afreen. Okay. Now the next question is something here like the first question that we did. The first question, it was a bit complicated.
Sir, voice
Two
is
times we
breaking.
repeated it. Voice is breaking. Afreen.
No, sir.
Now the first question that we did here, it was a bit complicated because here 4, 9, 16, 20, it was not directly an AP. 5, 7, it was a different, that differences were in AP. So we applied this method 2 times. Similar question I'm giving you now. 5th and then now 6th. Evaluate. S is equals to 1 plus 4 by 7 plus 9 by 49 plus 16 upon 343, 343 7 cube, okay, plus so on and so on and so on. General term is n square multiplied by 1 upon 7 to the power n minus 1. So on and so on. You have to calculate this sum up to infinite terms. Why I'm writing this way? halfway you must have done, I think so. So x multiplied by s and then subtraction. Yes or no?
Yes, sir.
X multiplied by s, and if I do the subtraction, then this will be x. Here it will be 4x square. Here it will be 9x cube, 16x to the power 4, and so on and so on and so on. So subtract on subtraction, this becomes 1 minus x times s is equals to 1 plus 3x plus 5x square plus 7x cube plus 9x to the power 4, and so on and so on and so on. Now here probably you might have got stuck. After this, are you able to do?
No, sir.
This is now think that this is again the arithmetical geometric series. This
Sir,
was
here we have to take common x, sir.
here x you cannot take common. If you take x common, then it will be what's a 3 plus 5x plus 7x square plus 9x to the power 4. How can you add that? You cannot add them.
Yes, sir.
See, the difference here is the previous questions 1, 4x, 7x square, 10x cube. So x, they were forming an GP. X square, x cube, x to the power 4, GP. But the coefficients, they were directly in the form of an AP. 1, 4, 7, 9, 1, 4, 7, 10, 13, and so on. So on this position shifting method, we were able to take 3 common. Means that differences of 3 was common. Here 1, 4, 9, 1, 4, 9, 16, 25. This is not directly a this is not directly an arithmetic progression. However, there are differences is in arithmetic progression. 3, difference of 3 that we have done, difference of 5 that we have done, difference of 7 that we have done, difference of 9 that we have taken. So if I would have given you this question, evaluate 1 plus 3x plus 5x square plus 7x cube. Isn't this question repetition of the previous questions? So see, x square, x cube, x to the power 4, it is geometric progression. 1, 3, 5, 7, 9, and so on. This is a arithmetic progression. So but up to where the point you're getting confusing is that, so up to this point, to calculate this step, we have already done some calculations. So you think that now, sir, we'll have to take x common. Don't get binded by that method. Just repeat it. If this 1 minus x, if this is confusing you, so just replace it temporarily by some other variable. Let's say call this equal to y, let's say. This whole thing is equals to y is equal to this much. So if y is equals to this much, now this arithmetic or geometric series, can you solve? Yes, sir. So what you will do? So I will do x times y. X times my y, whatever it was there. So x times y, now I'm again repeating that step. So here it is x, 3x square, 5x cube, plus 7x to the power 4, and so on. Now do the subtraction. So it will be 1 minus x times y, which is 1 plus 2x plus 2x square plus 2x cube plus 2x to the power 4, and so on. Yes. Now observe here that this is this here is a geometric progression. This way it is a geometric progression. 2x is the first term, multiplied by x, 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 and so on. Got it? So this y now resubstitute here. So it will be 1 minus x. What is y? Y itself is 1 minus x into s. So 1 minus x square multiplied by s is equals to 1 plus this geometric progression. First term is 2x and common ratio is x. Or if you want, you can take 2x as common and 1 plus x square plus x cube and so on up to infinite terms where modulus of x is less than 1. So this is 1 minus x whole square into s. This is equals to 1 plus 2x into a upon 1 minus r. A upon 1 minus r is 1 minus x. What was my x? My x was 1 by 7. So just resubstitute 1 by 7. 1 by 7 if I resubstitute, is equals to, this will be x plus 1 upon 1 by 7 plus 1 upon 6 upon 7 whole cube. You do the substitution, do the calculations. The answer turns out to be 49 upon 27. Done?
Yes, sir.
Yes, sir.
So now the last part of this is left of sequence and series. Applications of inequality. AM greater than or equal to geometric mean greater than or equal to harmonic mean. Okay. So the questions on this is something of the format. Prove that if A, B, C are positive real numbers, then A plus B plus C multiplied by 1 upon A plus 1 upon B plus 1 upon C is always greater than or equal to 9. This is your hint. AM, GM, HN.
So at last, what I will answer it is 9 or G, sir.
9. Okay, see. 1 upon A, 1 upon B, 1 upon C. Can you think that this might have something to do with harmonic mean? And A plus B plus C, this might have something to do with arithmetic. This must have something to do with arithmetic mean. And 1 upon A, 1 upon B, 1 upon C, this may have something to do with geometric harmonic mean. Yes or no? For
Yes.
A, B, C, all of them, if they are greater than 0. So arithmetic mean. Okay. From now onwards, we will denote arithmetic mean by capital A only. Geometric mean by capital G and harmonic mean by capital H. So arithmetic mean will be what? So arithmetic mean is A plus B plus C upon 3. Yes or no? And what is harmonic mean? So harmonic mean is something about 1 upon H. 1 upon H is the arithmetic mean of 1 upon A, 1 upon B, 1 upon C. Means I'm doing this rough calculation. 1 upon H is the arithmetic mean of 1 by A, 1 by B, 1 by C. So that is same as 1 by A plus 1 by B plus 1 by C upon 3. So can I write H, harmonic mean of ABC, is equals to 3 upon 1 by A plus 1 by B plus 1 by C. This is the definition of arithmetic mean and geometric mean. Now, what result do we have? We have that, sir, A is always greater than or equal to H. Since the A, capital H, they are arithmetic mean, geometric mean, or are of positive term numbers. So the equality will occur if small a, small b, small c are equal, but that we don't know. So capital A, arithmetic mean greater than or equal to a harmonic mean. So A plus B plus C upon 3 is always greater than or equal to 3 divided by 1 upon A plus 1 upon B plus 1 upon C. So just multiply it. But while multiplying with this variable, you are just multiplying it. But while multiplying with the variable, you have to be cautious whether or not to change the inequality sign. The inequality sign will not change, it will remain as it is, because the variable with which you are multiplying, it is a positive number. Yes or no? If that variable would have been negative number, then the signature would have changed. So this greater than or equal to 9. Prove. That's what was our result. Got it? Yes or no?
Yes, sir.
Okay. Second, if it is given to you that A plus B plus C is always equal to 5, their addition is equal to 5, it is fixed, where A, B, C are all positive. Okay, it means you cannot take the case that, sir, I will take A is equals to 12, then B plus C will be, let's say A is equals to 12, B is equals to 8, 12 plus 8, 20, and C is equals to minus 15. That is not possible. All three of them should be positive. So if all three of them positive and their addition equal to 5 is a constant, the question is find the greatest value of A cube, B square, C to the power 5, C to the power 4. Okay, I will explain this. It's actually a very new type of problem. See, how to do this questions is I will also tell you the thought process, how to think over these questions. Now see, a plus b plus c is equals to 5. This is given to me as constant. Okay. Now this here it is something to do with addition, and here it is something to do with multiplication. A into A into A, B into B into, and C into C into C. This much hint you should get that if I'm giving it, if I've already told you that right now we are doing sums of AM greater than GM greater than HM. So maybe here if the application would be of which inequality? Arithmetic greater than or equal to geometric, because geometric mean has everything to do with multiplication and arithmetic mean has everything to do with addition. Yes or no? So the only question remains is, should we choose A, B, and C as the terms whose arithmetic mean we're taking? So if we say that arithmetic mean of A, B, and C greater than or equal to geometric mean of A, B, and C, this is 100% correct because A, B, C are all positive. But this result will not be useful to us because what we will have, A plus B plus C upon 3 greater than or equal to A multiplied by B multiplied by C. It's complete raised to 1 by 3. Yes or no? And we do not want the product A into B into, sir, A plus B plus C we know what is the value of A plus B plus C, that is 5 by 3. So but this will give me A into B into C. We are not interested in A, B, C. We are interested in cube of A, square of B, and fourth power of C. Okay, this is not a, means although a correct result but not a useful result for us. So another approach, another second try if we give, discard this approach. Another approach if we give, let's say sir A cube you want now. So let me, instead of taking geometric mean of ABC, if I take geometric mean of A, 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 B, B, and C, 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 C. 3 repetition. A is repeated 3 times, B is repeated 2 times, C is repeated 4 times. So if I'm writing here geometric mean of these many terms, means what? 7 terms are there. These 9 terms, sorry. These 3 terms are all positive. These 2 terms which are again positive. These 4 terms which are again positive. These 9 terms. So here also, here I will have to write arithmetic mean of, not ABC, but A, B, B, C, 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 C. So that will give me what is the arithmetic mean? A plus A plus A, B plus B, C plus C plus C plus C, completely divided by 9. Are you getting it? Arithmetic mean definition. Addition of all the terms divided by number of terms. This is greater than or equal to, geometric mean is what? A into A into A, B into B, C into C into C into C, complete 9th root. So now this is again a 100% correct result. But again the same problem. So A cube B square C raised to the power 4. This we have got. But the problematic term is what's a 3A plus 2B plus 4C. This is not known to me. This is a big question mark. We know A plus B plus C. We do not know 3A, 2B, 4C. So no. And in the first approach that was there, this was a big question mark. Correct. So very cleverly we will combine these two methods. Means how we will combine them. So we want arithmetic mean of greater than or equal to geometric mean of. So you wanted the multiplication of A, whatever term is that A, the multiplication should come 3 times. That means whatever term you're writing of A, it should be repeated 3 times. So instead of writing that is fixed yet, yes sir, it will be repeated 3 times. A. But as soon as you wrote here A, the addition here went to be equal to 3A. Means the addition here. So here also you will have to write arithmetic mean of A, and then the addition, when you will add them, the addition will become 3A. So that is a problem. So what I will do is, sir, if my target was, sir, if I could make this addition equal to A only. So how can you make that addition equal to A? We will not take here A plus A is 3A. We will not take here A. We will take here A upon 3, A upon 3, A upon 3. So now my addition becomes A. Can you see this? So here also I will take A upon 3, A upon 3, A upon 3. So B repetition, the product B should be repeated 2 times. So product B should be repeated 2 times means what? B and B. So here also you will be forced to take arithmetic mean B and B. But then the product will, in the addition wise, it will be 2B. So I do not want 2B. I want B only. So here instead of B, if I could make it as B, instead of 2B, if I could make it as B, how can you make the addition as B only? B upon 2, B upon 2. Yes, the addition is B. So here also I will take B upon 2, B upon 2. And lastly, C to the power 4. C to the power 4 is there. This is my intended target. So C to the power 4, it is there. So I will write C upon 4, C upon 4, C upon 4, C upon 4, which makes, here it is C upon 4, C upon 4, C upon 4, C upon 4. So which makes the addition as C. Got it? So this is right. This is a right result. Yes or no? Arithmetic mean of these weird terms. These are all weird terms. A by 3, A by 3, A by 3, B by 2, B by 2. AM of these all positive terms greater than or equal to geometric mean of all these positive terms. What is the addition? The LHS, on the LHS, arithmetic mean is A upon 3, A upon A upon 3, A upon 3, A upon 3, the addition. B by 2, B by 2 addition. C by 4, C by 4, C by 4 addition. This complete divided by 9. Realize that there are 9 terms. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is greater than or equal to A upon 3, its product, B upon 2, its repeated product, C upon 4, its repeated product, complete ninth root. Okay. So this will be now substitute a plus b plus c. 5 is given to me. So 5 upon 9 is greater than or equal to a cube b square c to the power 4 divided by 3 cube 2 square 4 to the power 4 complete raised to 1 by 9. So the final answer will be a cube b square c to the power 4 is less than or equal to, here it will be 5 by 9 multiplied by, 5 by 9 whole to the power 9. Yes or no? 5 by 9 whole to the power 9, and this denominator which was there on the RHS denominator, RHS the denominator which was there, I will multiply it over here. So this will be 3 cube 2 square multiplied by 4 to the power 4. So a cube b square c to the power 4 is less than or equal to, no need to calculate these values. These values will be something 5 raised to 9 multiplied by 2 to the power how much? So this is 4. 4 means 2 square. 2 square means 2 square complete to the power 4 means 2 to the power 8. 2 to the power 8 and this 2. So this will be 2 to the power 10 divided by 3 to the power, this is 3 square. 9 is 3 square and this 8. So 3 to the power 18. 3 square. 2s are 9s are. 2 9s are 18. 3 to the power 18 and this 2 over here. So it will be 60. This will be the answer. So the greatest value is equals to 5 raised to 9, 2 to the power 10 upon 3 to the power 60. Wait, I did something wrong over here. Yeah, it should be 3 cube over here. Wait a minute. It should be 3 cube. So this will be 15, not 16. Is this clear to you, students?
Yes, sir.
Yes, sir.
So the only thing is you should be able to get these coefficients properly. A by 3, A by 3, A by 3, B by 2, B by 2. Okay. So here the sequence series chapter is completed. Have a nice day, everyone. Thank you. Do you need to take the screenshot? Shall I end the session?